Oh, sorry. There was a purpose behind that, actually. Paper football, for those that haven't played it, very fun game. Got to make it through the uprights. And uprights, remember, it has to go right through the uprights, otherwise you don't get the points. For those that follow football, American football, got to get through the uprights. Okay, you don't want to go left of it, you don't want to go to the right through it, you want to get right through the middle of it, right in there, and not outside of it. Okay, inside of it. Got to focus on the inside of the uprights. Why am I stressing that so much? Because with an absolute value inequality or equality, you got to focus on what's in the uprights, okay? Pretend these absolute value bars are uprights. That -2 over there, it's in the way. I need to get the absolute value bars by itself, right? Just like when you play American football, you want to get that football right between the uprights. You don't want to care about what's on either side. You're focused on what's inside, right? So let's get rid of that -2. To do that, divide by -2. That's the very first thing you want to do. Get these uprights by themselves. Now, we're going to divide by -2, which means this inequality is going to switch. So now we're looking at the absolute value of x minus 5 is greater than a -5. Notice this is not an and situation anymore. It started out as an and, right? It was less than. We talked about ands before. To be an and, it would have been less than or equal to. And to be an or, it'd be greater than or equal to. This one started as an and, but it's really an or. All right, so make sure to isolate for your absolute value first before you do anything else. Now, this problem is actually kind of a trick problem, because I can tell you right now what the answer is going to be. The answer is going to be all real numbers. Because when can the absolute value be positive? All this, after you take the absolute value, it's going to end up positive, right? In the end. And a positive number is always greater than 5. Your answer? All real numbers. Okay? Suppose that wasn't the case, though, all right? I mean, I just now made that discovery. Suppose we had a whole different situation. So I'll create a new problem here. Make it real quick. Let's do, say, the negative of the absolute value of x minus 2 is less than a -3. So we divide by a -1 first, right? Because that's like a -1 right there. So now we've isolated for the absolute values. That's what I tried to do. This sign switches, so it's going to be an or. So now we're looking at the absolute value of x minus 2 is greater than 3. Now you've got two cases to look at here, okay? So you got the positive case and the negative case. We talked about this before when doing absolute value equations. The absolute value or the positive case is exactly what you see. X minus 2 is greater than 3. The negative case is x minus 2, wait for it, it's less than a -3, okay? So like we did with absolute value equations, this 3 becomes a -3. And since we're introducing a negative, it's kind of like dividing both sides by that -1 there. It's going to switch that inequality. So when you introduce that negative, that sign switches as well. So two things are going to switch when it comes to the negative case of an inequality. So maybe I'll make that note. Two things to watch for. Okay. This sign here and this sign here. So we'll go ahead and solve them. We'll add 2 to both sides. X is greater than 5. We'll add a 2 to both sides here. X is less than a negative 1. But we've got an or. That's going to be important now, okay? Let me put this up here on the number line now. So we got values that are bigger than 5, but less than a negative 1. Bigger than 5, less than a negative 1. So here's our bigger than 5. Here's our less than 1. Now, had this been an and, or had this been less than, my answer would have been no solution, right? Because I don't have anything in common there. Just based off what you see off the graph. If this was a less than sign, things would have been a little different. I'm not going to go there. But this is an or, not an and. So remember, the answer is what you have that shows up in the answer. It's in the answer. So negative infinity to negative 1 parentheses, union, parentheses 5 to infinity. And there is your answer for that problem.